All right, so we're going to go over again, talk a little bit more about the unit circle, break it down a little bit more, and then also go over reference angles. So the unit circle is a circle, again, with the radius of 1. And then we know all circles go around for 360 degrees, or 2 pi if we're talking about radians. So each quadrant is broken down into 90 degrees. So the first quadrant is from 0 degrees to 90 degrees. Second is 90 degrees to 180 degrees. The third is 180 to 270. And then the fourth is 270 to 360. And then if we're talking about it in radians, it's 0 to pi over 2 for the first quadrant. The second quadrant is pi over 2 to pi. The third quadrant is pi to 3 pi over 2. And then the fourth quadrant is 3 pi over 2 to 2 pi. So we know that we have all of these special relationships because the unit circle looks at special right triangles 30, 60, 90, and 45, 45, 90 to get their exact coordinate points. So remember points, the points are always going to be in XY form. So when we're working with this unit circle, we need to be working with our trig functions, our 6 trig functions, and the definitions that we know of how those functions are defined to find specific values. So if I'm working with these examples again, I'm going to start. We have our sine of some angle is y over r. Our cosine is x over r. Cosine of some angle. Tangent of some angle is y over x. And then we have our cosecant is the reciprocal of sine is r over y. Secant's our reciprocal of cosine. R over x, and then our cotangent is x over y. So what you need to do again, find that point wherever it is on the unit circle in our measure, find what the point is, and then plug it into what we know of how these functions are defined. So this first example, sine of pi over 4. If I go pi over 4 is in quadrant 1, the point is radical 2 over 2, radical 2 over 2. And since I know I have a radius of 1, I'm only going to be working with, it's simply my y value. So this is radical 2 over 2. The cosine of 7 pi over 6. So 7 pi over 6 is on the unit circle. So then that's when we go and we have our x value. Our x value of that point is negative radical 3 over 2. The tangent of 5 pi over 3. 5 pi over 3 is in quadrant 4. So if I'm looking at quadrant 4, tangent is y over x. So to solve for this, I have to take my y, which is negative radical 3 over 2, and then I need to divide that by my x, which is 1/2. So remember, when we divide by a fraction, that's the same thing as multiplying by its reciprocal. So this is negative radical 3 over 2 times 2. So those 2's cancel out, so that leaves me negative radical 3. So the tangent at that value is negative radical 3. The secant of 10 pi over 3. So remember, the first step, what we need to do is we need to ask ourselves, is this on the unit circle? 10 pi over 3 is not on the unit circle. So we know that that's not going to work. So what we need to do is find an angle that is coterminal with 10 pi over 3 that is on the unit circle. So that's when we need to add or subtract 2 pi. Since this is a positive radian measure, we're going to be subtracting 2 pi. So to find that, we do 10 pi over 3 minus 2 pi. And since we want our like denominators, we're subtracting 6 pi over 3, so that gets me 4 pi over 3. 4 pi over 3 is on my unit circle. It's in quadrant 3. So I know that my secant is r over x. So my x value at that point is negative 1/2. So this secant value is going to be 1 divided by negative 1/2. And again, when we divide by a fraction, it's the same as multiplying by the reciprocal. So this is 1 times negative 2, which gets me negative 2. So the sine of 11 pi over 4. Again, 11 pi over 4 is not on the unit circle. So I need to find a coterminal angle that is. So we need to subtract 2 pi. If I have a like denominator, that's going to be 8 pi over 4. So this gets me 3 pi over 4. 3 pi over 4 is in quadrant 2. So the sine of 3 pi over 4 is that y value. So that's radical 2 over 2. The cosine of pi, if I look at pi, the cosine, the x value, -1. Cosecant of 2 pi. So if I look at 2 pi, my cosecant is r over y. So when I do that, I get 1 over 0. Remember, when I have a 0 that is in the denominator, I can't have that because I can't divide by 0, so this value is undefined. The tangent of 3 pi over 2, if I look at 3 pi over 2, tangent is y over x, so that gets me -1 over 0. I have another undefined value. And then finally, cosine of pi over 3 is in quadrant 1, the x value is 1/2. All right, so then we have our reference angles. So remember the reference angle, these are angles that are formed. These angles that are formed by the terminal side of an angle and then the x-axis. So if I'm in quadrant 1, this is going to be my reference angle. If I'm in quadrant 2, this is going to be my reference angle. Quadrant 3, this is going to be it. And then quadrant 4, that's going to be my reference angle. So reference angles are really helpful because if you know kind of the coordinates of the different values of the first quadrant, and then you know the different signs that we went over in class of the sine, cosine, and tangent of each quadrant, then you'll easily be able to get what value you're looking for if you can find the reference angle. So when I'm working, again, in degrees and radians, there's different ways for us to calculate what this looks like. So if I'm in my first quadrants, the way that I find my reference angle for both degrees and radians is it's just the angle itself. If I'm in quadrant 2, I need to subtract the angle from 180 or from pi if I'm working in radians. If I'm in quadrant 3, I need to subtract 180 or pi from the angle itself. And then if I'm in quadrant 4, I need to subtract the angle from either 360 or 2 pi, depending on if we're working on radians or if we're in degrees. So for these examples, so I have 225 degrees. So I look, first thing I have to ask myself, is 225 degrees on the unit circle? And the answer to that is yes. So 225 is in quadrant 3. So since I'm working in quadrant 3, and this is in degrees, I'm going to be using the formula theta minus 180. And all that you need to do, I give you theta. So you just need to go ahead and plug that in. So 225 minus 180, and that gets me 45 degrees is my reference angle. If I look at -240, -240 is not on the unit circle. So since that's not on the unit circle, I need to find where on the unit circle is coterminal with this angle. So to find a coterminal, I need to add 360, and that gets me 120. 120 is on the unit circle, 120 is in quadrant 2. So then we know that since we're working then in quadrant 2, we're going to be using the formula 180 minus theta. Again, you want to plug in what measure is coterminal to the measure that you're given, but you have to make sure that you plug in the one that's on the unit circle. So this is going to be 180 minus 120, so my reference angle here is 60 degrees. If I look at 11 pi over 6, now I'm switching to radians. 11 pi over 6 is on the unit circle, and it's in quadrant 4. So I use my quadrant 4 formula in radians, which is 2 pi minus my angle measure. So this is going to be 2 pi minus 11 pi over 6. And what I want to do with this 2 pi, again, we want our like denominators. So I need to change that into 12 pi over 6 minus 11 pi over 6. So when I do that subtraction, that final answer gets me pi over 6. If I have negative pi over 4, again, I look at my unit circle that is not on my unit circle. So I need to find that. So I do negative pi over 4. Since this is negative, I have to add 2 pi. So if I want like denominators, I'm going to be adding 8 pi over 4, and this gets me 7 pi over 4. So I'm working with this angle measure of 7 pi over 4. That is on the unit circle. It's also in quadrant 4. So I'm going to be doing 2 pi again minus 7 pi over 4. And I already found what 2 pi is. It's 8 pi over 4. So 2 pi over 4 minus 7 pi over 4. And that gets me pi over 4 as my reference angle.